Alright, this is a help video on a particular problem that's in section 6.4, and it deals with distributions of variance. So here's an example. 3 houses are randomly selected and surveyed. The number of people in the households are 1, 4, and 10. Assume that samples of size n equals 2 are randomly selected with replacement from the population of 1, 4, and 10. Listed below are those samples. So when they're picking 2, all the possibilities from picking 2 of the 1, 4, and 10. So they could pick 1 and 1 because it is with replacement, so they can put 1 back in. 1 and 4, 1 and 10, 4 and 1, 4 and 4, 4 and 10, 10 and 1, 10 and 4, and 10 and 10. So these are your samples, and your population is 1, 4, and 10. So part A asks you to find the variance of each of the 9 samples, then summarize the sampling distribution of the variances and include their probabilities. So how often are you going to get that particular variance? All right. So let's look at what we need to first do. So they give you a chart in MyMathLab, and if you notice already, the chart does not contain 9 different variances. So we know some of these variances are going to repeat. Before we get started, make sure that you have recalled or have somewhere in your notes your formulas you're going to need. You're going to need your population standard deviation formula and your population variance formula, your sample standard deviation formula, and your sample standard deviation. I said that twice. In your sample variance formula. Okay. And notice that your variance is just your standard deviation squared. So for the first part of the problem, we're going to use, since they tell us it's a sample, we're going to use the sample standard deviation and then square it to get the sample variance. So we're going to use these formulas first. Let's go over and make sure we know what these values are. Remember, x bar is the mean. X bar represents the mean of the sample. And n is the number or the sample size. Okay. When we go to the second part of the question, we're going to use the population standard deviation and variance. But right now, for the first part of the question, we only need to use the sample because they're asking about what is the variances, what are the different variances that could pop up with that sample, and what's the probability of those variances popping up. So let's go and get started on that. We're going to first look at what type of variances could happen. Okay? So standard deviation, I'm going to do a secondary kind of work chart. I have a sample of 1, 1. And then I'm going to need to think about what's the mean, what's the standard deviation, and from there I can get the variance. And then from there I'm going to say, oh, what's the probability of that variance showing up? Okay? Now when I think about the mean and the standard deviation, I'm going to need the mean to calculate the standard deviation, but the standard deviation tells us on average how far away is any particular point of the sample from the mean of the sample. So if you're looking to see how far away they are, well, if the numbers are identical, they're not distant from the average of them. They're exactly the same. So when the numbers are identical, the standard deviation is 0. And if the standard deviation is 0, the variance is 0. Because variance is simply the square of the standard deviation. Now, look at your samples. You have 1, 1, 10, 10, and 4, 4. All of those are going to produce means that are exactly the same. They don't deviate from their mean. That is 3 samples out of 9. So the probability of getting a variance, all right, so they are not going to deviate at all. 1 is 0 away from 1, 10 is 0 away from 10, and 4 is 0 away from 4. So we have the standard deviation is 0, so therefore the variance is 0, and this happens with 3 of our 9 samples, so the probability of getting a variance of 0 is 1 out of 3. Now let's look at the next possible outcomes we could have. We have 1 and 4. But notice that when you're talking about how far they deviate, meaning the average distance, 4 and 1 and 1 and 4 behave the same. Let's calculate the mean. So 1 plus 4 divided by 2, that is 5 divided by 2 is 2.5 is our mean. And likewise, if you did 1 plus 4 or 4 plus 1, you get the same mean. So they are the same. Okay? And then your standard deviation, you take the square root of and here you're summing each point minus its mean. So 1 minus 2.5 so 1 minus 2.5 squared plus taking the second element 4 minus 2.5 squared divided by the number in the sample size, which is 2 minus 1. And you're going to take the square root of all of that. Notice that the same standard deviation is true for either 1 and 4 and 4 and 1. So this works out to be the square root of 4.5, which is approximately 2.121. Now, the variance is just the square root, is the square of the standard deviation. So if you squared square root of 4.5, you would get 4.5. So your variance is 4.5. How often does this variance occur? It occurs for the sample 1 and 4 and 4 and 1. That's 2 out of our 9 samples. So the probability of getting a variance of 4.5 is 2 over 9. Now looking at our next set, our sample is 10.4, and the sample 10.4 is going to behave much like identical to the sample of 4.10. So we need to calculate our mean. 10 plus 4 divided by 2, and we're dividing by 2 because we have a 2, we're taking the average, so you add them up and then divide by how many you have. 14 divided by 2 is 7. And notice that this would be the same whether you take 10 plus 4 divided by 2 or 4 plus 10 divided by 2. So now we have to calculate our standard deviation. You take your entry, your x value, minus your mean. So 10 minus 7 squared plus 4 minus 7 squared. And divide that by your sample size, which is 2 minus 1, which ends up being 1. So when you calculate that, you have the standard deviation of the square root of 18, which is approximately 4.243. Squaring your standard deviation to get your variance. Your variance is 18. Your variance occurs for 2 of the 9 samples, so that's 2 over 9 is your probability of getting a variance of 18. On your last set, we have one sample of 1 and 10. That's going to behave much like a sample of 10 and 1. It's going to behave identically mathematically. So 10 plus 1, let's find our mean, divide by 2, is 11 divided by 2, which is 5.5. Find your standard deviation. So you take your value, your sample value, 1 minus your mean, 5.5, squared, plus 10 minus your mean of 5.5 squared, and divide by 2 minus 1, which is your sample size minus 1, because we are dealing with the standard deviation of a sample. So you have to use the n minus 1 formula. Simplifying that, you get the square root of 40.5, which is approximately 6.364. To get your variance, you take the square of the standard deviation. So the square of square root 40.5 is 40.5. And this occurs 2 out of 9 times. So when we look up at the table that they give you in my math lab, we have the variance of 0, and that occurs 1/3 of the time. The variance of 4.5, that occurs 2 of the 9 times. The variance of 18, that occurs 2 of the 9 times. And the variance of 40.5, that occurs 2 of the 9 times. Okay? Now, the next thing it asks you to do in part B is it wants you to compare part B. So part B of the same problem is to compare the population variance to the mean of the sample variance. Okay? So the first thing we're going to do is get our population variance. So our population variance, recall your formula, very similar to the sample variance, but it's this. We're going to sum up our values minus our mu. Mu represents the mean of the actual population divided by n, the n being the population size. Okay. So if you recall back in the problem, our population was our 3 original households that was sampled, which is 1, 4, and 10. Okay. So the first thing we need to do is get our mean of our population. 1 plus 4 plus 10 divided by 3. That's 15 over 3, which is 5. Now we want to calculate our variance. So we're going to add up our entry minus our mean squared plus our next entry minus our mean squared plus our third entry minus our mean squared, all of which divided by our population, which is 3. Notice here we're not doing the n minus 1 because this is population versus a sample. That's the difference, and that's probably where a few of you are making an error. So let's go ahead and calculate that. And hopefully it will work out nicely. I believe it works out to 14. Yeah, let's take a look. 15 plus 1 plus 25 divided by 3. Yes. So our population variance is 14. Now, that's our population variance. Now we want to look at the mean. So we're talking about an average of the sample variance. Okay? So get that chart back up and let's look at it. Remember our variances? We had our variance 0 appeared 1/3 of the time, or 3/9 of the time. 4.5 appeared 2/9 of the time. 18 appeared 2/9 of the time, and 40.5 appeared 2/9 of the time. So we want to just take a mean, and the easiest way to do that is just add them up and divide by how many you have, which should be 9. So getting our mean of the variance, and this is of the sample. So 0 has no effect, but you do have 3 times that 0 will appear in your variance. You have 4.5 that will appear twice in your variance. 18 will appear twice, and 40.5 will appear twice. And divide all of that by 9. When you add that all up and divide by 9, you will find that your variance, your mean of your sample variance, is 14. So they are the same. So notice that they are the same. And one of the reasons that Part C is that it targets the population variance. Okay? So it targets it, and therefore it is a good representative of your population variance. Well, I hope this helped, and please email me if you're still having difficulty with this particular problem.